It is 1 mile across. It is a whopper. It is what is called a nation buster. It'll knock out just London or New York. It'll knock out North America.
The strange world of astronomy has expanded greatly. Imagine a football-sized space rock that is speeding across space and acting unlike anything we have ever seen. This isn't your typical space junk fragment. Scientists are perplexed by it, and onlookers are reacting with a mixture of wonder and trepidation. This object appears out of nowhere. It doesn't obey the rules because its speed makes no sense and its path is completely off. It appears to have independent thought. And just when you believe you've seen everything, it accelerates and changes course, throwing you into a loop. There isn't a logical explanation. What is the matter with this strange interplanetary object? Could this be evidence of something or someone out there? Join us as we explore the Oumuamua and how it's causing the impossible in the vastness of space. The 2017 comet Oumuamua captivated both scientists and the general public with its enigmatic name. The first extrasolar visitor ever seen lacked the characteristic luminous coma and dust tail of comets, had an unusual form, something between a cigar and a pancake, and was too tiny to be anything other than an asteroid. Objects hurled into interstellar space originate in other planetary systems and are propelled there by the gravitational pull of gas giant planets that are constantly ravaging their neighborhood, or by massive collisions that tear protoplanets apart. Oumuamua sheds light on the nature of additional extrasolar planetary systems as the first known interstellar visitor. Being the earliest known interstellar object in our solar system, its name comes from the Hawaiian word meaning a messenger from afar arriving first. How appropriate. The telescope that found it, Pan-STARRS 1, is located in Hawaii, thus the Hawaiian name was chosen accordingly. Also noteworthy was the form of Oumuamua. At first glance, the object appeared to be 10 times longer than it was wide, giving it the appearance of a large cylinder. The original measurements were 6.6.1, but astronomers eventually adjusted them to more accurately depict a pancake form. Astronomers have seen similarly shaped objects in the Kuiper Belt beyond Neptune, specifically a minor planet called Arrokoth, which NASA's New Horizons spacecraft flew past on New Year's Day 2019. The measurements of Oumuamua's shape and dimensions were based on its light curve, a graph that tracks how the object's brightness changed over time as it tumbled through space. Oumuamua appeared brighter when we saw its broader side. Also, Oumuamua was diminutive, measuring just 377 feet in length, 364 feet in width, and 62 feet in thickness, according to its albedo of 0.1. This indicates that it reflected 10% of the sunlight that fell on it, which is typical for cometary nuclei. Astronomers were able to trace Oumuamua's orbit as more and more telescopes pointed at it, and they found that it had completed one full orbit around the Sun and was now leaving the solar system. It was believed that Oumuamua was very elongated and falling on its ends due to its uneven brightness changes that occurred every 12 hours. Also, unlike asteroids, comets exhibit a little but noticeable acceleration away from the Sun. As comets approach the Sun, they expel dust and gaseous comas made of water and other substances from their surfaces. Usually, one tail is visible as dust that the comet left behind, and the other is a second tail that points away from the Sun, along with some inertial push. This second tail is caused by vapor and particles that are pushed by the light pressure from the Sun. Entrapped organic molecules and carbon monoxide are among the other substances that can be released. Because of its extremely tiny size, Oumuamua's gravitational deflection around the Sun was marginally affected by the little push produced when hydrogen gas spurted out of the ice, setting it apart from all other comets in our solar system that have been extensively examined. From their distant origins in the solar system, most comets make periodic approaches to the Sun, like filthy snowballs. A comet's ejection of water and other molecules caused by solar heating results in a luminous coma, and in many cases gas and dust tails. A little kick from the released gases causes the comet to deviate slightly from the elliptical orbits typical of objects in our solar system, such as planets and asteroids. Astronomers speculated widely about the composition and the force propelling Oumuamua outward when it was detected without a coma or tail, too small to collect enough energy to release a significant amount of water, and too far from the sun. The outgassing of hydrogen gas by an iceberg of hydrogen, a large fluffy snowflake pushed by light pressure from the sun, a light sail created by an alien civilization, a spaceship under its own power. As ice objects that lingered from the solar system's birth some 4.5 billion years ago, comets provide scientists with insight into the circumstances surrounding that time. Other stars encircled by disks that could one day host planets can be inferred from the behavior of interstellar comets. Comets provide a window into the solar system's makeup during its protoplanetary disk stage of evolution. Their study provides a window into the early stages of solar system creation, when our solar system was much smaller and less massive. Astronomers know that comets have been ejected from faraway planetary systems as a result of gravitational interactions with other objects in the system, just as happened in our solar system's past. There should be an opportunity to learn about planet formation in other systems when some of these rogue comets periodically visit our solar system. The exact location of Oumuamua's stellar system is a mystery to all. Nevertheless, in 2018, researchers traced Oumuamua's return to its original route toward the sun and discovered that, 1 million years ago, the object passed close to 4 stars with the red dwarf star HIP 3757, being its closest contact. Maybe that's where Oumuamua originated, or maybe it has been roving around space for a lot longer. The solar system's planetary bodies, asteroids, and comets all follow tight orbits around the sun. A NASA animation explains that Oumuamua's trajectory was hyperbolic, meaning that it approached the sun at such a high speed that its route could only be minimally bent by the sun's gravity, rather than being captured in a looping circle. That means Oumuamua could keep on going towards the exit door of the solar system at a relative velocity of 16.36 miles per second to the sun's motion. Astronomers didn't spot Oumuamua until after it had made significant inroads into our solar system. It reached perihelion, its closest point to the sun, on September 9, 2017, when it got as close as 23 million miles to our star. It wasn't until over a month later, on October 19, 2017, that University of Hawaii astronomer Rob Warwick discovered Oumuamua in observations made by the Asteroid Hunting Panoramic Survey Telescope and Rapid Response System. At that time, Oumuamua was 21 million miles from Earth, and its trajectory eventually brought it as close as 15 million miles. From that point on, the extraterrestrial guest has been making its way out of our solar system, with NASA detailing how Oumuamua was propelled to a speed of 54.2 miles per second by a gravity boost from the sun. Due to its small size and rapid ephemeral motion, Oumuamua could only be observed for a short period of time, the Hubble Space Telescope being the instrument that could follow it for the longest period of time. By merging data from 2 of the world's largest optical telescopes, the Very Large Telescope in Chile and the Gemini South Telescope, the finest photos of Oumuamua, like this one, could reveal the star as tiny as a speck. Oumuamua has departed from Neptune's orbit and is now en route to Pegasus. It has slipped beyond our observatory's reach as it travels through the Kuiper Belt, a ring of frozen objects located near the solar system's periphery. It has no intention of ever returning to Earth. What exactly Oumuamua was is a matter of conjecture. We know it was an object that was thrown out of Oumuamua's orbit by the gravitational waves of roving gas giants, since it originated in an extrasolar planetary system. Before Oumuamua was discovered, astronomers expected interstellar objects to be comet-like, which ended up being the case for 2I Borisov. For a long time, astronomers assumed that Oumuamua was just a dead comet, whose volatiles, or gases with low boiling points like water, evaporated over billions of years, either while it was still in its original system or while it was close to other stars, since it didn't produce a cometary tail. Nevertheless, Oumuamua's outward route from the sun showed evidence of non-gravitational acceleration according to the Hubble Space Telescope. This is a common occurrence for comets, as they gain more momentum as they release water vapor and dust in a tail. However, Oumuamua did not emit any of the volatile substances or water that are often seen in comets. Two main theories propose possible meanings for Oumuamua. One theory puts Oumuamua as a block of nitrogen ice. It comes from Arizona State University's Alan Jackson and Steve Desch. Areas like Sputnik Planitia were basically frozen nitrogen lakes that New Horizons saw in 2015 as it swooped past Pluto. Jackson and Desch speculated that Oumuamua could be a piece of nitrogen ice blasted off a Pluto-like body in a massive impact. The extra push that Oumuamua needed could have been provided by outgassing nitrogen, which is sublimated by the sun's radiation. Because nitrogen gives comets a more reflecting albedo of 0.64, Oumuamua would have had to be smaller than originally anticipated to have seemed so pale. According to the calculations done by Jackson and Desch, the dimensions of Oumuamua would be a mere 148 by 144 by 25 feet if it were constructed from nitrogen ice. Cosmic rays may have reacted with surface ice while Oumuamua was in interstellar space, freeing hydrogen from some water molecules and creating a supply of hydrogen gas trapped in amorphous water ice, according to another theory put forth by Cornell University's Daryl Seligman and Berkeley University's Jennifer Bergner. The idea put forth by Seligman and Bergner states that the interstellar object Oumuamua was warmed as it crossed the sun, but not to the point where the water ice would have evaporated. The reported push in Oumuamua was really caused by hydrogen escaping at a rate of 0.4 to 28 ounces per second, which was made possible because the heating altered the structure of the ice crystals. Since the dust would remain trapped in the water ice, this would also explain why Oumuamua did not have a dust trail that could be seen. According to a theory put out by astronomers Avi Loeb and Shmuel Bialy of Harvard University, the Oumuamua was a solar-sailed spaceship because of the non-gravitational acceleration. Having said that, the vast majority of astronomers reject this notion. Most things in the universe obey some kind of power law distribution, where there are a small number of large members of the group and a lot of small members. Maybe Oumuamua is somewhere in the middle. We really have no idea how many interstellar objects could be passing through the solar system at any one time. There are some estimates that there are between 1,000 and 10,000 interstellar objects in the solar system at any one time. Wow. Of course, almost all of these are in the distant solar system, and we'd never be able to see them. You might roughly guess that these objects more or less appear to be coming from the direction in which our solar system is moving through space, in the same way that when you are driving in the rain, all the raindrops look like they are coming straight toward your windshield. Oumuamua and Borisov are galactic nomads who spend the majority of their time roving through interstellar space, in contrast to the normal solar system asteroids and comets that orbit the sun. Although scientists had speculated about the possibility of such extraterrestrial visitors to our solar system, they had anticipated their rarity. These two findings have led scientists to believe that extraterrestrial visitors are considerably more prevalent. According to planetary scientist David Jewett of UCLA, there may be approximately 10,000 interstellar objects, the size of Oumuamua now within Neptune's orbit alone. Scientists are occupied with attempting to deduce the origins and methods of propulsion for these extraterrestrial bodies as they scuttle across the galaxy. Additionally, extraterrestrials may offer a novel approach to studying faraway planetary systems. However, astronomers must first locate additional of them. Astronomers have speculated about the existence of extrasolar objects at least since the early 1700s. Recent computational simulations have demonstrated that, long ago, as a result of gravitational interactions with the giant planets, the solar system expelled its own population of smaller things into the gaps of interstellar space. Most extraterrestrial visitors were thought to be exocomets made of ice elements, according to scientists. Borisov was a perfect match since its tail was composed of gases and dust generated by ice that melted as it drew near to the sun. This points to its possible genesis in a planetary system's outer area, when carbon monoxide and other gases were frozen into the rocks due to extremely frigid temperatures. Something kicked Borisov out of its system at some point. One potential culprit is a stellar flyby. A recent study conducted by Pfalzner found that smaller bodies, called planetesimals, can be ejected from the outer regions of a system by the gravity of a star that is passing through. From the outer reaches of a planetary system, an object can be ejected by a big planet if an asteroid or comet approaches closely enough to be accelerated enough by the planet's gravitational pull to break free of its star's grip. Planets can also get close together when they move across their solar systems, as is believed to have happened with Neptune in the early solar system. However, scientists were surprised by Oumuamua. In contrast to Borisov, it exhibited no signs of gas or dust activity, which could indicate that it formed at a warmer temperature closer to its star. If that were the case, the object would have remained in its system even after a star flyby or a massive planet attempted to remove it. As an alternative, it might have been expelled as the star was dying. The gas pulses from a dying star have the potential to propel planets and planetesimals further out into space, causing enough orbital instability to send some of them hurtling into interstellar space. But it's also conceivable that Oumuamua formed in the icy outer regions of its system and acquired a gas tail that observatories missed as it got closer to the sun. The fact that the object's acceleration exceeded what could be predicted by the solar system's gravity alone provides one possible indicator. According to a new study, the telescopes might have missed tiny amounts of hydrogen outgassing, which could have caused such an enhancement. Another study found that other asteroids in our solar system may have received a similar boost from the outgassing of water vapor. Little outgassing may be detected in future investigations by the James Webb Space Telescope and the JAXA Hayabusa 2 extended mission, which will encounter one of these asteroids in the solar system called dark comets in 2031. We'll have to wait and see, but they could be analogs of Oumuamua. Some of these mysteries might be solved with additional data collected from additional invaders. Scientists will require improved detection probabilities of the objects as they orbit the solar system if they are to collect these data. Astronomer Robert Warwick, who formerly worked at the University of Hawaii, detected the extraterrestrial object in the data collected by Pan-STARRS. He claims that if the telescope hadn't observed the same spot that night, the discovery of Oumuamua would have never happened. Astronomers hope that the Vera C. Rubin Observatory's upcoming legacy survey of space and time will improve their chances of detecting these fast movers. The observatory's telescope will begin imaging the entire visible southern sky every few nights, starting in 2025, and its primary mirror is nearly 7 meters larger than Pan-STARRS 1, so it can see fainter objects farther away. In the event that extraterrestrial objects are identified, both terrestrial and orbiting telescopes will take pictures of them to identify their composition. And if an attainable target is found, the Comet Interceptor, scheduled to launch in 2029 by the European Space Agency and the Japan Aerospace Exploration Agency, might be steered to take close-up images of the guest. After all, scientists are hoping to compile a database of all interstellar objects that is comparable to the exoplanet inventory, which has amassed more than 5,500 entries since its initial discovery in 1992. In the future, scientists may be able to use that inventory to finally determine how typical Earth and the solar system are. Potentially habitable extrasolar bodies can be better understood by analyzing the chemical compositions of a wide variety of interstellar objects. The fundamental components of extrasolar planets are planetesimals. They can give information about the variety of habitats, including ones that might be livable, which suggests that they are relevant. At this point, both Oumuamua and Comet Borisov have slipped outside of Neptune's orbit. Their return to interstellar space is an adventure whose outcome is anyone's guess. Maybe a star will capture them, or maybe they will spend all eternity lost in space. Alternatively, they might disintegrate into a dust and gas disk in an entirely different solar system, where they could start their adventures anew. The really cool thing is that interstellar objects come to us